we're going to recap some vocabulary and some basic ideas of algebra. Let's just remind ourselves about some of the conventions of algebra. If I write 3y, I mean 3 multiplied by y. Similarly, if I write 2x plus 1, I mean 2 multiplied by x plus 1. The basic story is, in algebra, I often don't write the multiplication sign. And so when you just see 3y, you must know that it is 3 multiplied by y. The other thing I often don't write in algebra, is this. If we have 1y, which just means 1 multiplied by y, we conventionally in algebra just write that as y. Then here's a little vocab that we need. What I have here is an algebraic expression, and it's got these component parts. Variable comes from the English word vary, and if we say something varies, it means it changes. So the variables in this expression are x, y, and z, because these are the things that can take on different values. So the variables here are x, y, and z. Constant, on the other hand, is almost the opposite. It's the thing that doesn't change, that doesn't have any different values, and the only thing that's not going to change its value is this. It's the 4, and we mustn't forget to put its sign with it. So the constant in this expression is negative 4. The coefficient is just the number that multiplies a variable. So the coefficient of x here is 5. The coefficient of z is 2. The coefficient of y, if you have a look here and just remember what we just said, there would be a 1 here that we just don't bother to write. So the coefficient of y is negative 1. So let's write that down just to have a note of it. The coefficient of y is negative 1. And then terms in an algebraic expression are things that are separated by the addition and subtraction sign. So in this expression here, we've got 1 term, we've got 2 terms, 3 terms, 4 terms. So in this case, we have got 4 terms. And then we have some algebraic expressions that have special names. A monomial just is an expression with only 1 term. For example, 5x. A binomial, bi like in bicycle, etc., 2, it's an expression with 2 terms. So here we've got 5x plus 3, 2 terms. And a trinomial, tri like in triangle, etc., means 3. It's an expression with 3 terms, like this one here, where we've got 1, 2, 3 terms. And the last little word I want us to pop in today and remind ourselves of is this word evaluate. If we're asked to evaluate an algebraic expression, like evaluate x squared plus 2x when x is 3, what that means is work out the value of the expression where we put 3 in place of x. So here we'll get 3 squared plus 2 times 3, which is going to be 9 plus 6, which is 15. And we've evaluated x squared plus 2x when x is 3. Algebra is a language, and we need to know some of the basic rules of how to communicate using this language. Some of these are just conventions that make sure that we can all understand each other and that we're using the same signs to mean the same things. So let's first look at something like 3x, which you'll see a lot of in algebra. What this means is 3 multiplied by x. So in algebra, we very frequently do not write the multiplication sign, and we simply write 3x to stand for 3 times x. You would have a similar thing too if you wrote, for example, 2x plus 4. This means 2 times x plus 4. A very different story to 3x is x cubed. X cubed, that exponent means that you've got x times x times x. X multiplied by itself 3 times. Now, related to both of these is the idea that with 1, we often don't write it in algebra. So, 1x, we could write that. It just means 1 times x. But the convention in algebra is that we simply write x. So if you see x just like that, it means 1 times x, one lot of x. And similarly, we don't bother to write x to the power of 1 because x to the power of 1 would mean just, like x squared means x times x, x cubed means x times x times x. X to the power of 1 means you've just got 1x, and so it's just x that we write it as. If you have something like 6b times a minus a, this 6b times a needs to be done first. Now, you can't actually do very much with that, except in algebra we tend not to write the minus sign. So we could just write that as 6ba minus a. And then most people like to, for conventional algebra, to put their letters in alphabetic order. So instead of saying 6ba, it's just a bit prettier to say 6ab minus a. And say we had something like 3 plus p times 5. Again, we have to do multiplication first. So we could write this as 3 plus, and we could write p5 because in algebra we don't write the multiplication sign. But also in algebra, where we have a letter and a number, we prefer to put the number first. So we'd rather write it as 3 plus 5p, and more often than not, we will start off with the terms that have got letters in them before we write numbers. So none of these are wrong, these are perfectly decent, but this is the most conventional way to express it. If you have something like this, where you've got a with negative b in brackets, what you mean is a multiplied by negative b. And you can actually write that more nicely as you've just got a times b and it has to be negative. And so it will be nicely written as negative ab plus 10. All of these that I'm showing you here are just conventions so that we all write algebra in a similar way. As I said before, these other ways of writing it are perfectly understandable. We can read them, and so they're fine, but they are just the more conventional ways of writing things in algebra. We're going to look at different representations of algebraic expressions. We start with it in words. So we start by saying, let's multiply a number by 3. And we'll represent that as saying we're going to take the number, feed it into the machine that multiplies by 3. Then we're going to add 8 to the answer, so we need to add on the other machine, which adds on 8. Now let's use a number as an example to see how this would work. So if we start with 2, and we feed it through the machine that multiplies by 3, we'll get out 6. Then we take that 6 and feed it through the machine that adds 8, and we'll come out with the answer of 14. Now we're going to do that same thing, but now we're going to use x to stand for any number. So we start with x, and we feed it through the machine that multiplies by 3, and we get out 3x. Then we take that 3x and we feed it through the machine that adds 8, and we'll end up with 3x plus 8. So what we see is that 3x plus 8 is the algebraic expression that represents the instruction multiply a number by 3 and then add 8 to the answer. Let's try just reversing those two statements. So let's start this time by adding 8 to the number and then multiplying the answer by 3. So that would be the flow diagram that represents that statement. Let's again show what will happen with a number. So we take 2 and we add 8 to it, and out will come 10. Then we take that 10 and we multiply it by 3, and out will come 30. Now let's go and use x, so we get an algebraic expression. So we take x, which can stand for any number, and we say, first of all, we need to add 8 to it. So what will come out is x plus 8. Now we need to take that whole x plus 8, so I'm going to put it in brackets, and multiply it by 3. And out will come 3 lots of x plus 8. So 3 brackets x plus 8 is the algebraic expression that represents the statement add 8 to a number and then multiply the answer by 3. Let's go over what it means to evaluate an algebraic expression. If we're asked to evaluate bc minus a squared, what we're being asked to do is figure out the value bc minus a squared will be when we put in place of b 2, in place of c 3, and in place of a 4. Before we do this, we just need to make sure that we can read our algebra correctly. So when we write bc, it means b multiplied by c. So what we've got is 2 multiplied by 3. And then after that, we need to subtract a squared, and a, we are told, is 4. So it's 4 squared. 2 times 3 is 6. And 6 minus 4 squared is 16. So we've got 6 subtract 16. And that's going to get us to the answer of -10. Let's do another example. Why don't you try this one? You're being asked to evaluate x squared times x plus 1 when x is -3. Pause the video and try it now. Okay, so wherever you saw an x, you needed to put a -3. So remember, it's the whole of x that's squared, so it's the whole -3 that gets squared. And then you have -3 plus 1. -3 squared is -3 times -3, which is 9. And now if you take -3 and you add 1, you get -2. And remember, when you've just got these two things next to each other, it means multiplication. So 9 multiplied by -2 gets me to -18. Let's look at equivalent algebraic expressions. These are expressions that look different, but actually mean the same thing. Like x plus x is the same as 3x. Let's have a look at these expressions here and evaluate them at these values. So for example, when a is -3 and b is -2, let's look at this. Well, we don't have to worry about b because there isn't a b in this one. So a is -3. We're going to get 4 times -3, which is -12. Then we're going to get 3 times -3, which is -9. -12 plus -9 is -21. And then we have to add on 2, so we're going to get -19. When a is 0, we're going to get 0 plus 0 plus 2, which is 2. And when a is 3, we're going to get 12 plus 9, which is 21, plus 2, which is 23. For this next row, I am going to have 7 times 3 is -12, 21 plus 2, it's negative 19. And the rest are easy, we'll fill them in quickly. For 7a squared plus 2, I have to take 7, and then I've got to take negative 3 and square it. Negative 3 squared is negative 3 times negative 3, which is 9. 9 sevens are 63, plus 2 gives me 65. And again, we'll work out the other two in a similar way, and there are the answers. For this 7a plus b, when a is negative 3, I'm going to have 7 times negative 3, which is negative 21, plus b, so plus negative 2. Negative 21 subtract 2 is going to give me negative 23. And then for this last one, we're going to have 7 times negative 3, which is negative 21, times negative 2, which is going to be positive 42. And again, we'll fill in the other two in a similar way. Now, one question I want to ask myself is, which of these are equivalent expressions? And now, hopefully, you see that 4a plus 3a plus 2 can be simplified, because 4a plus 3a, these are like terms, and so you'll get 7a. So 4a plus 3a plus 2 is equal to 7a plus 2. These two are equivalent expressions. And you'll notice that because they're equivalent expressions, they have exactly the same values for any different value of a you choose to put in. Now, sometimes people get a bit confused, and then they see 4a plus 3a, they think the answer should be 7a squared. So someone might think that 7a squared plus 2 is equivalent to 4a plus 3a plus 2. But if you just substitute in some values, you will see that substituting in negative 3, you get a very different answer here to here, and that immediately tells you that these two are not equivalent. Similarly, some people think that if you say 7a plus b, you can just collapse it all together and say 7ab, so they'd think these two are equivalent. Now, hopefully you immediately know that's not true, because 7a plus b, 7a and b are not like terms, so you can't actually simplify this anymore. And 7ab means 7a times b, so it's not the same as 7a plus b. But similarly, if you just substitute in some values, you will see you get very different answers for 7a plus b to 7ab. So these two are definitely not equivalent expressions.